Hello everyone. In this product training module, I will be presenting the basics of DC power as well as the types of cables used for DC application. So what is the difference between in AC and DC power? The main difference between AC and DC power is the direction of the electrons flow. Both AC and DC describe the types of current flow in a circuit. In direct current DC, for example, the electric charge or current only flows in one direction. So the flow of direct current does not change periodically, as you can see. The electric charge in alternating current, on the other side, changes direction periodically. So the voltage in AC circuit also periodically reverses because the current changes direction. Examples of devices that use DC are battery-operated devices such as torch, car battery, or solar. On the other hand, AC is used for powering industrial buildings, household appliances, and industrial loads such as motors. In this slide, let's take a look at the typical construction of a DC cable. As you can see, DC systems are of a two-wire type, of which a DC power has two terminals. One is a positive and the other one is a negative. So a DC power cable basically consists of two conductors. One is the red, which is being the positive, and the other one is the black, which is the negative. So the current flows from the positive terminal to the external circuit and returns back to the negative terminal. Voltage rating for DC cables. Cable voltage rating are specified in this format for DC application, where the U0, which is the 0.9 kilovolt, is the voltage rating between the conductor to earth. And the U, which is basically the 1.5 kilovolt, is the voltage rating from the conductor to conductor. The 0.9 kilovolt is the active to earth DC voltage rating, whereas the 1.5 kilovolt is the active to active DC voltage rating of a cable. So let's take a look at the Tri-Cub range of cables used for DC application. Tri-Cub offers different range of cables both in copper and aluminum conductors for DC application. These cables are the FB, DC, and HB in figure 8, which is designed in low smoke zero halogen jackets, and these cables are rated between 90 to 125 degrees rating temperature. The other set of cables are the DL, RL, and the RW STIs, and also the KB figure 8. These cables are manufactured with e-rubber jacket. And these cables are offered with an option of 90 or 110 degrees conductor temperature. So where do we use DC cables, or what's the typical application for the DC cables? DC distribution is limited to use in situations such as tram and traction system, with a voltage of usually 600 volts. Railway DC traction system with a voltage of 1.5 kilovolts between the rail and the overhead collector wire. DC cables can also be used for lifts, printing presses, and various machines where smooth speed control is desirable. DC cables are also used in solar panels as well as battery charging. DC current is also commonly used to power small electronic devices such as mobile phones, computers, radios, or even hybrid and electric vehicles. So, can we use AC cables for DC application? Well, technically yes we can, but however DC cable is designed with two wires only, which is the positive and the negative. And the structure is very simple, whereas AC cable is manufactured with 3-core, 4-core, or 5-core. Therefore, AC cable can be more costly compared to a DC cable because of the number of wires. Current ratings for DC application. Current ratings for DC cables are similar to those in single AC cables. The following four tables can be used as the DC current ratings. For DC SDI cables, copper single core 90 or 110 degree can be used. And for the 2-core DC cables, copper 2 core 90 or 110 degrees cables can be used. So this is the end of the product training module. Thank you so much for watching.